Hey guys, I'm just doing the second part of the 2015 and 2016 matrices exam. So this is going to be all the short answer questions. All right, I'll get straight into it. We've got question 1. Okay, we've got students in a music school. Okay, they're classified according to 3 ability levels. All right, so they're either in beginner, intermediate, or advanced. Okay, we've got the initial state matrix below, okay, which lists the number of students at each level in the school for a particular week. I might zoom this in a bit more. All right, so question A, how many students in total are in the music school for that week? All right, so quite a nice question. We just add up the 20, the 60, and the 140. Okay, so we've got 120 students. Okay, to start with. All right, the music school has 4 teachers. All right, we've got David, Edith, Flavio, and Jeff. Each teacher will teach a proportion of the students from each level as shown in the matrix P below. All right, so that's the proportions. All right, so matrix Q we can get by doing our initial state matrix times P. All right, that can be used to find the number of students from each level taught by each teacher. Okay, so question B, complete matrix Q shown below by writing the missing elements in the shaded boxes. So on your calculator, guys, you would have just done our initial state matrix, okay, times P, okay, and you would have got this matrix Q. All right, and what we're going to do is fill in those missing values, so it would have been 10 and 9. Okay, question 2. How many intermediate students does Edith teach? All right, so if we're trying to work out that, I'm just going to quickly show you something. So if we look at matrix Q, okay, that was our initial state, so S, all right, times by our P matrix. Okay, and if we think about this, is just a handy thing if you're trying to work out what the elements might mean. Okay, we know when we're multiplying matrices, we do this little rows by columns. Okay, the columns are the first. Okay, I have to match up with the rows of the first. Okay, so these two numbers have to be the same. Okay, our resultant is going to be our rows and our columns. But one thing you can do as a little trick, okay, we see that our resultant, okay, is going to be our rows and our columns. A handy little thing you can do is if you look at matrix S, okay, the rows there were our ability levels, so beginner, intermediate and advanced. Okay, so that's actually going to be the same for matrix Q. So beginner, intermediate, right, and advanced. Okay, so if we go back, it's going to be the rows by the columns of P. So the columns of Q are going to match the columns of P. So in matrix P, we had all of our music teachers. Okay, so that's going to match up here. D, E, F, and G. All right, so that's just a handy little hint if you're trying to work out what the elements mean. Okay, the rows of the first will match up with the columns of the second, and that's going to match up even with the resultant, okay? So just makes it a little bit easier. So how many intermediate students does Edith teach? Okay, we can look at that now. All right, and we can see it's 30. Cool. All right, moving on. The music school pays the teachers $15 per week, okay, for each beginner student, $25 per week for each intermediate student, and then $40 per week for each advanced student. All right, those amounts are shown in the matrix C below. Okay, the amount paid to each teacher each week can be found using a matrix calculation. Write down the matrix calculation in terms of Q and C that results in a matrix that lists the amount paid to each teacher each week. Okay, so quite wordy, but what it's saying is we want to do a matrix calculation in terms of Q and C. that's going to tell us how much each teacher is paid each week. So one handy way you can do this is actually write the order for both matrices. So I'm going to look at our matrix Q. All right, that's a 3x4 matrix. So Q is a 3x4 matrix. Okay, we can see C above. All right, C is a 1x3 matrix. Okay, if we're going to do a calculation or a multiplication of these two matrices, the only way it's going to work, okay, is if we multiply C by Q first. Okay, because these threes are going to match up that way. So it has to be CQ. All right, question 2, how much is paid to Jeff each week? Okay, so what you'd do is you'd actually multiply the C and Q together. Okay, remember the rows of the first one, so the rows of C was the dollars. Okay, it's going to match up with the columns of the second one. So the columns of the second one were our teachers. Okay, so if you multiply them together, you're going to get a 1x4 matrix. Okay, and Jeff, if we look back at Q, Jeff was in the fourth column. Okay, so whatever this value is, just in the fourth column, this value here, that's how much Jeff's going to be paid each week. All right, which should have been the answer of $340. Okay, so if you just multiply C and Q together, you're going to get a 1x4 matrix, and Jeff is in the fourth column. All right, moving on. Okay, the ability level of students is assessed regularly. Okay, they're classified as beginner, intermediate, or advanced. Okay, matrices is very worded. Okay, we've got it. After each assessment, students either stay at their current level or progress to a higher level. Okay, students cannot be assessed at a level that is lower than their current level. Okay, the expected number of students at each level after each assessment can be determined using the transition matrix below. Okay, what it's saying is students at the three levels can move up the ranks. Okay, they cannot move down the ranks at all. All right, so A, the element in the third row of the third column of matrix T is the number 1. Explain what this tells you about the advanced level students. Okay, so this 1 here, what it's saying is if a student was in the advanced level before the assessment, okay, it means they're going to stay in that advanced level. So you say students in the advanced level. All right, there's a number of ways of writing this question, but students in the advanced level will stay there after each assessment. Cool. All right, let matrix SN be the state matrix that lists the number of students at beginner, intermediate, and advanced levels after N assessments. The number of students in the school immediately before the first assessment of the year is shown in the initial state matrix below. Okay, so we've got our initial state, 20 in the beginner. Okay, we've got 60 in the intermediate, right, and 40 in the advanced levels. Question B, write down the matrix S1 that contains the expected number of students at each level after one assessment. Okay, write the elements of this matrix correct to the nearest whole number. Okay, so if you're a highlighter person, okay, we're trying to find S1, and it just wants us to write the elements of the matrix, so find the matrix. Okay, and then to the nearest whole number. So remember with the matrices, guys, if the number is 4 or below, okay, we round down. If it's 5 or above, okay, we round up. All right, so what we're going to do is find S1. Okay, to do that, use our transition matrix, okay, and then times the value before, which is our initial state. So if you wanted in your calculator, you could define this transition matrix up the top as T, okay, and then times it by that initial state. That'll get you S1. All right, so if you did that, you'll get a 3 by 1 matrix, okay, with 10, 58, and 52. Okay, and that's going to be the beginner, intermediate, and advanced levels, the number of students in each level. Question 2, how many intermediate level students have become advanced level students after one assessment? Okay, so if we look at the number of students who were in the intermediate level before the assessment, okay, we see it's this 60. And what we want to know is how many of those students, those intermediate level students, have become advanced level students. So we get that via our transition matrix. Okay, so we see that 60 were intermediate before. All right, 20% of them, if I can highlight, 20% of them are going to become advanced. All right, so you can just do 60 times the 0.2, okay, which will get you 12 students. All right. Question 3. A new model for the number of students in the school after each assessment takes into account the number of students who are expected to leave the school after each assessment. Okay, so now we've got, after each assessment, students are classified as beginner, intermediate, advanced, or they've also could have left the school. Okay, let matrix T2 be the transition matrix for this new model. Okay, matrix T2 shown below contains the percentages of students who are expected to change their ability level or leave the school after each assessment. Okay, so now we've got a new transition matrix. Okay, so we've now got students who potentially have left the school. All right. Question A, an incomplete transition diagram for matrix T2 is shown below. Complete the transition diagram by adding the missing information. All right, so the way I did this, okay, and you can do it a number of different ways, is I actually just cross them off one at a time, just to be really thorough. So what I did is I looked at the transition matrix, the transition diagram. Okay, and I just went left to right. We see that 30% of beginner students stayed at the beginner level. Okay, so that 30% in the matrix is there. Okay, then I saw, so I just went through it from beginner to left the school, 25%. Okay, and I just, crossed them off as I went. So beginner to A, 5%. Doesn't matter which ones you cross off first. Beginner to I was 40%. All right, so some of these are not going to match up. All right, any values of 0, okay, you don't need to add them into the transition diagram, so that's fine. All right, so I'm just going to cross these off as I go. 20 to 20. Just make sure you're writing off the right ones. Okay, this 10% from intermediate to have left the school. Okay, we can't see the 10% on the diagram, so that information's missing. Okay, so 10% from intermediate to have left the school. All right, now I've got that. Okay, the 75% in advanced and advanced. 25% from advanced to have left. Okay, and the last one we've got is the 1. So number of students who have left the school will have stayed left. So that's 100%. All right, so just one way of being thorough if you wanted to just cross them off one by one. Cool, moving on. All right, the number of students at each level immediately before the first assessment of the year is shown in the matrix R below. Okay, Gee, it's so wordy. I'm just going to say we've got our transition matrix there as well. All right, question B, what percentage of students are expected to leave the school after the first assessment? Okay, so what we've got to do there is it wants it as a percentage. What percentage of students are expected to leave the school after the first assessment? Okay, so if it is as a percentage, we can see, guys, that we had 120 students in the assessment initially. So we've got this 20, the 60, and the 40. So of the 120, how many have left? Okay, we get that from the transition diagram. So if a student was in the beginner level, okay, 25% of them are going to leave. So 20 were beginners, 25% of them are going to leave. And then you just go through. Okay, we had 60 that were intermediate. Okay, 10% are going to leave. All right, 40 were advanced. Okay, 25% of them are going to leave. Okay, and we've got no students who have left, so we don't have to worry about that. Yeah. All right, so if you do that calculation, all right, and then times it by 100, you'll get the percentage, okay, which is, what have I got here? I got it, 17.5%. Cool. All right, question C. How many advanced level students are expected to be in the school after 2 assessments? Okay, so all we want to do is just find advanced level students, okay, after 2 assessments. So we're going to be finding S2. Okay, so if you want, you can do the transition matrix to the power of 2 times the initial state. If you want to do it quicker, you could do it by recurrence 1 by 1 as well if you wanted. All right, that would give you a 4 by 1 matrix. Okay, and we want to know advanced level. So this was beginner, intermediate, advanced, and left. So it's going to be the value that's in that third row. Okay, so if you do that calculation in the third row, that value should have been 43 students. All right, question D. After how many assessments is the number of students in the school, correct to the nearest whole number, first expected to drop below 50? All right, so the way I did this question, you might have done it differently, but I just did it via trial and error. Okay, so I actually started just with S4. And what we're trying to do here, guys, is we're trying to work out the number of students, I'll highlight it, the number of students that are still in the school. All right, and when that first drops below 50. Okay, so if they're in the school, okay, they're either at beginner, intermediate, or an advanced level. So we want to find, when we add those 3 values, when it's first below 50. Okay, so what I did was I just went straight ahead and found S4. Okay, I just had a stab in the dark, so found S4. Okay, and I found that these 3 values, so for the beginner, intermediate, and advanced, was still above 50. Okay, but I saw it was really close to 50. Okay, so then I found S5, did the same thing, and I found out that was when it was first below 50. So it's after 5 assessments. Okay, so a bit of trial and error there. Cool. Okay, so we've got another model. Essentially what it's saying is that we're adding students to the school after each assessment. Okay, so we've got students being added to the beginner, intermediate, and advanced levels of the school. All right, then it goes on to say we've got a recurrence relation, okay, where we can find the number of students at each level after so many assessments, okay? So it also gives us our initial state again, just so we don't have to flick back. Okay, so 20, 60, and 40 at each level. 0 have left. Okay, so question E, consider the immediate level students. All right, expected to be in the school after 3 assessments. How many are expected to become advanced level students after the next assessment? Okay, write your answer correct to the nearest whole number. Okay, so what it wants us to do is just look at immediate level students, okay, that are in the school after 3 assessments. So what we've got to do is we've actually got to find, okay, they've changed it from S, it's R. So we've got to find R3, okay, to work out this number of intermediate level students. Okay, with this guys, you have to do it via recurrence. Okay, you have to do them one at a time. It's a bit annoying, but because we're doing this addition each time, okay, we just have to do it one at a time. Okay, so what you do this equation 3 times, making sure that you're using the value before whatever that matrix is each time for the next one. Okay, and looking for that intermediate level, it's that number that's in that second row. Okay, so when I did it, I got, what have I got? 34 students, okay, at intermediate. Try 34 students I. Okay, after 3 assessments, then it wants to know how many are expected to become advanced level students, all right, after the next assessment. Okay, so what we can do is of that 34, we can use our transition matrix, okay, which was above, okay, to work out from intermediate to advanced, which is this value here. All right, that's 20% of them are going to become advanced. So of this 34, all right, 20% will become advanced, okay, which is, it'll round up to 7 students. All right. Question 1. Okay, we've got a travel company, right, which arranges flights, hotel, performance, and tour bookings. Okay, matrix C contains the number of each type of booking for a month. Okay, write down the order of matrix C. It's a nice one to start with. It's 4 by 1. Okay, a booking fee per person is collected by the travel company for each type of booking. Matrix G contains the booking fees in dollars per booking. All right, so what we can see, guys, is if a student, well, not a student, if a person decides they want to do a flight, okay, that's going to cost them $40. Okay, and we can see in a month they've got 85 people in this travel company choosing the flight. All right, and then so on for the rest of the values. Okay, calculate the matrix product J, okay, by multiplying G and C. Okay, so in your calculator, you put in G, multiply it by C, okay, and you should get 6,000, a 1 by 1 matrix. Okay, what it wants to know is what that represents. Okay, so put it in terms of the context of the question. So we can see that $6,000 is like a total value. Okay, but if we put it in context of the question or the scenario, we've got a travel company with 4 types of bookings, all right, and the cost for each of those bookings, that $6,000 represents the total amount of money that they've collected in the month. And that's from all their bookings. So the total amount of money collected by travel company. Okay, for the month. All right. Question 2. Okay, the travel company has 5 employees. Mara, Ben, Cheng, Dana, and Alka. Okay, the travel company allows each employee to send a direct message to another employee only, as shown in the communication matrix G below. Okay, we've also got G squared as well. So we know, guys, that if we've got these ones and zeros, that's just who can communicate with who. Okay, the rows mean the sender, columns is who's receiving it. Okay, in the G squared, okay, remember that's two-step communication. So how one person can communicate to another person with someone in between. Okay, so again, being the sender and the receiver. Okay, so question A, to whom can Dana send a direct message? Okay, so if you look in Dana's row, she can send a message to, who's that, Ben and Alka. Okay, question B. Cheng needs to send a message to Alka, okay, but cannot do this directly. Write down the names of the employees who can send the message from Cheng directly to Alka. Okay, so this is two-step communication. Okay, in the two-step communication, we can see that Cheng has 2 ways of communicating with Alka via someone else. Okay, what we want to know is who those people are. So what I'm going to do is I'm going to quickly rub out this, if I can. All right, so Cheng, he directly communicates with, is that Amara, Ben, and Dana? Okay, so if Cheng sends a message to Amara, okay, Amara can then send it to Alka because Amara can communicate with Alka. So Amara is one person. Okay, then I'm just moving along the ones in Cheng's row. So if Cheng communicates with Ben, okay, we can see that Ben can't communicate with Alka. All right, and this last one, Cheng with Dana, we can see that Dana can communicate with Alka. So it's going to be Amara and Dana. Dana or Dana. One of the two. So question 3. All right, the travel company is studying the choice between air, land, sea, or no travel by some of its customers each year. Matrix T shown below contains the percentages who are expected to change their choice of travel from year to year. Okay, if you're a skim reader, I think you can sort of tell it's just the transition matrix from one year to another. It's very wordy. You probably skim read. When it's got the actual question, don't skim read that, but this stuff at the start. Yeah. All right, so let SM be the matrix that shows the number of customers who choose each type of travel N years after 2014. Okay, we've got the initial state matrix, okay, which shows the number of customers who chose each type of travel in 2014. Okay, so we've got a travel company. Okay, we can see that 520 customers chose to travel by air. Okay, and in this transition matrix, we can see if a customer chooses one type of travel, okay, what they're gonna choose the next year. Okay, so matrix S1 below shows the number of customers who chose each type of travel in 2015. Okay, so to get S1, what we do is our transition matrix, okay, and times our initial state. Okay, question A, write the values missing from the matrix S1, D, E, and F. Okay, so what you do is put your transition matrix in, times it by the initial state, okay, which will get you D, E, and F. So those values were 298, 94, and 130. Okay, question B. Write a calculation that shows that 478 customers were expected to choose air travel in 2015. Okay, so we can see that there was 478 customers in 2015 that chose the air travel. Okay. What we want to do is know how they got there, okay? So what we've got to do is use our transition matrix. We've got our one from the year before, so 2014, up here. All right, so of the 520 customers that chose air travel, the number that will choose air travel again is 65%. Okay, so they're going to contribute towards that 478. Okay, so it's going to be 520 times 65.65. All right, and then you just work along the rows. So then we've got, I'll do a different color. We've got the 320 that chose land travel. Okay, 25% of them will choose air travel next year. So just work along that top row to get that calculation. So 320 times 25. Okay, and then just keep working. So we've got the 80 and the 25. And then we've got the 80 and the 50. Okay, and then that's going to equal the 478. All right, so that's that. Okay, question C. Consider the customers who chose sea travel in 2014. How many of these customers were expected to choose sea travel in 2015? Okay, so what we want to know is just the number of customers in sea travel. Okay, in 2014, I'll do it in yellow. That was that 80 customers there. Okay, and if they chose sea travel, the number that we're going to choose sea travel again, okay, is this 25%. Okay, so it's going to be the 80, of the 80, 25%, we're going to choose it again. Okay, which will be 20 customers. All right, question D. Consider the customers who are expected to choose air travel in 2015. Okay, what percentage of these customers had also chosen air travel in 2014? Okay, round your answer to the nearest whole number. Okay, so what we've got to do is we look at just the number of students who are choosing air travel. Again, if you're a highlighter, you can do that. So we want to see air travel in 2015 as a percentage, what had chosen air travel in 2014. Okay, so the total number that had chosen air travel in 2015 is at 478. 478 for 2015. Okay, so of these customers, which ones had also chosen air travel in 2014? Okay, so what we do is we look at the number of customers in 2014 that had chosen air travel. I might just rub all this out if I can. Okay, so that's that 520 there up the top. Okay, so 520 have chosen air travel. All right, and of those, okay, in the blue, we can see that 65% of them will choose air travel again. Okay, so of the 520, all right, 65% of them, we're going to choose air travel again. So this is 2014 to get to the next year. So of that, and because we want to get it as a percentage, all right, if I can rub this out. All right, if we want to get it as a percentage, we times that by 100%. Okay, so if you do that, all right, you're going to get 70, and it's going to round to 71%. Okay. Yeah, just take note if it wants it the whole number, okay, as well. Right, in 2016, okay, the number of customers studied was increased to 1360. All right, we've got matrix R shown below, contains the number of these customers who chose each type of travel in 2016. Okay, so we've got all the customers that chosen each type of travel. The company intends to increase the number of customers in the study in 2017 and 2018. Okay, so from the following years of 2016. All right, the matrix that contains the number of customers who are expected to choose each type of travel in 2017 and 2018 can be determined using the matrix equations below. Okay, so to find 2017, we use our transition matrix times the year before, okay, and add B, okay, which B we've got here. Okay, and then obviously to find 2018, we do the same again using the 2017 values. Okay, we've got our transition and our value of B. All right, question E. The element in the fourth row of matrix B is negative 80. Okay, so that's that value in there. Explain this number in the context of selecting customers for the studies in 2017 and 2018. Okay, so that column there represents customers who are doing no travel. Okay, that N represents no travel. All right, the common mistake here was that people said that 80 customers had chosen no travel. But if it's that minus 80, that means 80 people are actually leaving the study. Okay, if it was just 80, that means that 80 people are choosing the no study each year, but it actually means, because it's minus 80, that 80 people are actually leaving the study each year. Okay, so just 80 people each year are leaving the study. All right, question 2. Determine the number of customers who are expected to choose C travel in 2018. Round your answer to the nearest whole number. Okay, so if you are a highlighter, we just want the number of customers choosing C travel, okay, in 2018. Okay, so what we've been given is we've actually been given the 2016 values. All right, we're going to find 2017 using this recurrence relation. Okay, so in your calculator, you'd put T in, okay, times it by the year before, which is the 2016, okay, and add this B, okay, and that'll get you 2017. All right, and then I'll just rub it out. Do it again. Okay, to find 2018, what you'd have to do, I'm just rubbing all this out, is then use that answer which you found for 2017 times your transition matrix, add the B again, okay, and then that'll give you the matrix for 2018. Okay, for me, my matrix was a 4x1. I had 755, 536, and this is just all rounded. 190, 118, Okay, and sea travel was this third row. Okay, so it was 190 customers. Oh, supposed to be C, customers. Cool. So hopefully that helps, guys. Good luck with your study. You're going to smash the SAC next week. And yeah, looking forward to getting into the exam study as well. So, if you're getting heaps of exam questions done, the more exposure you get to them, okay, you'll have seen them before. So good work. Good luck for next week. Hopefully that helped as well.